Can you give us a little color on your smart antenna technology?
Sure. I mean, maybe it's a secret that we're not doing a very good job of getting the story out but the company was actually founded, and the business was originally predicated on our ability to deliver smart antenna technology, which for us means beamforming. So most access points, or pretty much every access point that's not a Ruckus access point, will have what we would describe as a dumb antenna. It's an omni antenna, which basically means that when you're transmitting, you just broadcast in all directions. So your average home AP from whichever vendor are those little rubber duck things that stick up. It's just a piece of wire inside a piece of rubber, and when the AP transmits, it sends the signal everywhere. Okay, now that's fine, except when you have a very limited amount of power, which legally you do in every case, varies by country. That's why when you set a country setting, when you're setting an AP up, but you don't have very much power. So when you're just broadcasting everywhere, by definition, in any one direction, you're limiting the amount of power that you have. So it would be a bit like being in a busy room. If I wanted to communicate to somebody and I had a loudspeaker, I would point to the ceiling and talk through the loudspeaker rather than aiming the loudspeaker at the person that I wanted to talk to. So what we have the ability to do is to aim the loudspeaker. Now the second thing that's important to understand with Wi-Fi is, whilst you might have many clients connected to an access point, the access point is only communicating with one device at a time. So it's a shared medium. It's like an Ethernet hub used to be, as opposed to an Ethernet switch. So 50 devices connected, but the access point will say, okay, now it's you, now it's you, now it's you, now it's you. So again, it comes back to this point. If you're broadcasting everywhere, but you're only communicating with one device at a time, that's not optimal. So if we can point that loudspeaker and keep moving it so that we're always aiming at the right client at the right moment in time, we can take the limited amount of power that we have, and we can ensure a much stronger signal, and the signal noise ratio is higher for that client, which means better throughput, higher signal noise ratio, so just overall better performance for the client. In addition to that, if interference occurs, we'll just find another path. So maybe instead of transmitting directly towards where you are, we'll move over here, we'll bounce the signal off the wall, go around the source of the interference, maintain the performance, whereas your average omni antenna access point will drop the phi rate. They'll start speaking more slowly, and that's when you get slow performance. Okay, so that's the way we work, and all that functionality is built in. It's automatic. There's nothing that you need to configure, and it happens on a packet-by-packet basis. Faster than packets can come in and out of the AP. It's always optimizing itself, and we have thousands and thousands of different antenna patterns we can create within every device. So it's been what's made the company what it is today.
Now, can a carrier remotely manage and tune that radio in accordance with whatever RF plan they have in building or out of building?
Well, yes and no. We don't. The antenna itself, all the smarts that I've just described, is an embedded function, so it happens automatically. But the simple way of thinking about it is, if you have an access point from anybody else, or if you needed 100 access points from anybody else, you can get away with deploying 50 access points from Ruckus. So the radius will just allow, the radius of coverage will just be that much larger that you need fewer APs. But in terms of getting into to tweak that, I mean, you would tweak the same kind of things, whether it's quality of service or rate limiting, those things. But the way that the RF actually works and the smart antenna works, that's an embedded function within the AP, and there's no real reason why you would need to get in to change that. So it's a proprietary feature of our product. But by the way, from a client standpoint, we don't care about the client. We'll work with any client, B, G, N, AC. It doesn't make any difference to us, and we'll bring the same benefit to that client.
So can you talk about how the smart antenna technology works with your smart cell gateway? All the smart antenna function from an RF standpoint is autonomous to the access point. Okay, the smart cell gateway itself is I don't want to simplify it to the extent to say it's a configuration and management tool. But that's one of the primary functions that it has. So that platform allows you to manage, configure, provide gateway tunnel termination to tens of thousands of APs but in and of itself, it doesn't relate directly to the RF function that's operating within the access point. As I said, that's an autonomous function within the AP.